showing you the exact methods experts use to turn base large language models into powerful, reliable AI agents. We will cover the core limitations of models like GPT-4, the secrets of prompt engineering in RAG, and how agentic workflows are building the future of AI. The base large language models you use, like GPT 3.5 Turbo or GPT 4.0, have significant limitations. Because they are pre-trained on historical data, they lack current information and specific domain knowledge. They struggle with narrow, defined tasks and are difficult to control, as seen when a notorious 2016 Microsoft Twitter bot quickly turned into a racist jerk and was removed just 16 hours after launch. Furthermore, even the best models have limited context windows, handling only hundreds of thousands of tokens, roughly the equivalent of 2 books. To overcome these flaws, we look at 2 main paths to improvement: upgrading the foundation model itself, or, more practically, leveraging the existing LLM through strategic methods. The most effective strategy is prompt engineering. Instead of a simple query like "summarize this document," you improve the prompt by specifying the task, audience, and format. A popular technique is chain of thought, which encourages the model to think step by step. We also use few-shot prompting, which gives the model a set of examples in the prompt to align its behavior. For complex tasks, prompt chaining breaks the problem into multiple debuggable steps, such as one prompt to extract key issues and another to write the final response. While fine-tuning, training the model on substantial labeled data, is possible, it is time-consuming and risks overfitting. This is why most production systems rely on Retrieval-Augmented Generation, or RAG. RAG integrates external knowledge like databases and documents to ensure answers are accurate, up-to-date, and grounded. Documents are converted into vector representations, and when a user asks a question, the system retrieves the most relevant documents and adds them to the prompt for the model to answer. This leads to the next evolution: agentic workflows. An AI agent is a workflow that combines prompts, memory for storing information about the user, and tools for interacting with external APIs. This system breaks complex problems into sequential steps: understanding intent, planning, using tools, and then reflecting on the results. This structured approach is what allows multi-agent systems to work together in parallel, speeding up complex tasks. As these systems are built, evaluating them is crucial. This includes both end-to-end user satisfaction and component-based evaluation, where each part of the workflow is tested individually. Looking ahead, the future of AI is defined by several trends. Scaling laws suggest that increasing compute will continue to improve models. Multimodality means models will learn from text, images, audio, and video together. And finally, the velocity of progress in combining different learning approaches is moving extremely fast.